Okay, so as in the last video we have discussed about solutions, right? We discussed the basics of solution, what actually solutions are, what solutions are made up of. So solutions were nothing but they were the homogeneous mixture of two or more substances which loses their individual properties and then cannot be separated by simple methods. Solutions were made up of two components or substances. They are generally made up of two components or substances. However, they can be made up of three or more than three too, right? But we are discussing here about general, right? So generally they are made up of two substances, which includes solute and solvent. Now we need to recognize what would be solute and solvent in the solution. Now see, if you find something in a smaller quantity in a solution, you must consider it as solute. And the thing you find in the larger quantity, you must take it as solvent, right? So we actually understood or comprehended by this examples as well. And I hope now these basics are clear that what solutions are and what solutions are actually made about. I told you about the homogeneous mixture as well. Homogeneous mixture is the uniformly distribution of solute throughout the solvent. Okay, so in today's video we are going to start discussing very important topic, right? So that is all about concentration terms, the concentration units in which you're gonna measure the concentration of the solute. Okay, so we have a lot of units, we have a lot of concentration terms, which of course we're going to study in today's video. So yeah, we are going to study today the concentration terms. Now see, we are going to divide these concentration terms in two categories so that it would going to become and easy for us to learn and comprehend this, that what properties would be there on what the temperature will affect and what would be there on what temperature will not affect. All right, so concentration terms we are going to divide them in two categories, sorry, in two categories. The first one is volume related. Here we are going to learn all the concentration terms which are related to the volume. So these are volume related. Volume related. And the second category of the concentration term would be mass related. See, so concentration terms are actually divided into two categories. The first category we made was volume related and the second we made is mass related. Now see, volume related would be dependent of temperature. I'll tell you why, wait for it. Dependent of temperature. And the mass related are independent of temperature. Independent of temperature. Now let's understand this, why we have actually divided the concentration terms in two categories. Now see, the first one volume related and the second one mass related. We have actually divided these concentration terms in two categories since we need to have an effect of the temperature. Now see, we know that if the concentration terms would be volume related, the temperature will of course will gonna affect on it, right? If we're gonna increase the temperature, the volume will be increased. If we decrease the temperature, the volume would be decreased. And this is what we studied in the Charles law, right? Temperature is directly proportional to the volume. But secondly, if the concentration terms would be mass related, the temperature will not gonna affect on it. They will be independent of temperature, right? So we actually divided concentration terms since we need to have a look on the effect of the temperature on the concentration terms. That's why we divided them into volume related and mass related. Volume related, the temperature would of course gonna affect them and they would be dependent of temperature. But the mass related, the temperature would not gonna affect them and they will be independent of temperature. Now see what things we will gonna study in the volume related and what concentration terms we will gonna study in the mass related concentrations, right? So here we will be studying the first one would be volume by volume percentage. Volume by volume percentage. Okay, so the first one would be volume by volume percentage. Second one here would be weight by volume percentage. Okay, so this would be weight by volume percentage. Weight by volume percentage. The third one here would be molarity. Now see, I know this you will find something that we need to learn this. No, of course you will not gonna learn this, and this is my guarantee. Since when we gonna deep dive into every concentration term, you will gonna get that is this mass related or volume related. So we're gonna understand each and everything. So molarity, the fourth, the last but not the least is normality. Molarity and normality. Okay, which is denoted by capital M and this is denoted by capital N. So see what we are gonna study in the volume related concentration terms. Of course, the first one volume by volume percentage. Okay, third one molarity. Second by weight by volume percentage. And the fourth one is normality. Now see here you will gonna find volume in it. Volume by volume percentage, of course here you can find volume. Weight by volume percentage, of course here you can find volume too. Okay, molarity, if you look at the formula of molarity, of course we're gonna deep dive into it, but this is for your understanding only. I'm telling you now, molarity is basically number of moles per unit volume. Moles per unit volume. So here you can find volume 2. Normality is basically number of gram equivalent, number of gram equivalent per unit volume. So here you can find volume 2. So in each term, volume, you can find volume. So this is why we have put them in the volume related, since they all are related with the volume. And if we're gonna increase or decrease the temperature on these terms, they will be affected, of course, since they are volume related. But if what we're gonna study in the mass related, the first one would be, of course, weight by weight percentage. Weight by weight percentage. Okay. Second would be Second would be, of course, molality. Molality. Of course, I'm not gonna here tell you in very detail for now since we'll be deep diving into it. But for now, I can tell you guys a formula. So the formula of it would be mass of solute upon mass of solvent. That too in kg, right? Third one here we will be studying would be ppb or ppm first. That is parts per million. Parts per million. Formula, of course, you can find here mass of solute upon mass of solution here in 200. Then the last one would be here parts per billion. Parts per billion, right? The formula same, mass of solute upon mass of solution in 200. Not 100 here, however 10 power 6, since we know that actually million is 10 power 6 and billion is 10 power 9. Okay. So if you see why are they related to the mass, since here you can find mass, okay, mass and mass of solvent, again mass. So see, all things are related with mass, means they will not be affected by temperature. So we again divided the concentration terms in two categories, volume related and mass related.